All right, so actually this is day 2. Okay, so what we went over on Friday with the polar coordinates and a little bit of review from pre-calculus is that the origin in a rectangular coordinate axis serves the same purpose as the pole in a polar axis. So if you have a point in the polar coordinate system, then that point is listed as r theta. So r is the distance of the point to the pole, and theta is the directed angle measure from the polar axis, which is the positive x-axis. So there's our theta, and the distance there is r. Now, one of the things that we took a look at on Friday was how we are able to relate this to the Pythagorean theorem and the regular trig that we have. So what we noticed is that if we create a right triangle here, then this distance r from the pole to our polar coordinate serves as the hypotenuse. So r squared is equal to x squared plus y squared. We also noted that the sine of theta is equal to y over r, or, more importantly, y is equal r sine theta. Similarly, cosine of theta is adjacent over hypotenuse x over r, or x is equal r cosine theta. And finally, the tangent of theta is opposite over adjacent, so that's equal to y over x. So those are 4 very important properties that we are going to use that will help us in our conversion from not only rectangular coordinates to polar coordinates, but from polar to rectangular as well. Okay? So let's take a look at an example. Let's say we have a point r theta that's equal to 2 comma pi. So what this is saying is that the distance of this point to the pole on the polar axis is 2 units at an angle of pi. Okay? So what are the rectangular coordinates for this point? Before we do that, let's take a look at what it looks like graphically. Okay, so here we have 1, 2. So we're 2 units from the pole at an angle of pi. So here's our pole here, 2 units here, but now the angle measure is pi, so that point is right there, 2 comma pi. Now, what do you think that point is in rectangular coordinates?
That's the r squared. That's the r squared.
It's not r squared. This is, so if I ask you to plot this point 2 comma pi in the polar axis, this is what it is. The distance from the pole is 2 units. The angle measure is pi. That angle right there is pi. So this is the point 2 comma pi in the polar axis. So what do you mean by r squared? Oh, what's the x comma y? So if this were just an xy axis, what point would this represent? -2, 0, right? All right, so let's see if that is in fact what happens. Now, what we're going to use, so for your x coordinate, we know that x is equal r cosine theta. Well, your r is 2, your theta is pi. So x is equal to 2 times cosine of pi. What's the cosine of pi? So 2 times negative 1, so the x-coordinate is at negative 2, which is what we can visually see happening there. Y is equal to r sine theta. So r is still 2, y is equal to 2 times sine of pi. Y is equal to 2, sine of pi is 0, so y is 0. So the corresponding rectangular point with the polar point 2 comma pi is negative 2 comma 0. So to convert from polar to rectangular, these two equations, x is equal r cosine theta, y is equal r sine of theta, are extremely important. I can't even stress how important these are. Wait till you guys start seeing the FRQs on these and how much you're going to refer back to this property here in your conversion. So if I were you in your notes, I'd just go ahead and mark up that really all 4 of these right here, those are going to be very, very, very important to you in this polar unit. Very important. Okay, let's take a look at rectangular to polar. So now you're going to take a rectangular point. So let's say x comma y, and that's equal to negative 1 comma 1. So xy is equal to negative 1 comma 1. What would the corresponding or equivalent polar coordinate be for that? Well, Well, if you take a look at this, so remember a polar coordinate is the distance to the pole and also the directed angle. So without going through the math here yet, what angle do you think this forms? 3 pi over 4. So this angle should be 3 pi over 4. How about the distance? Any way to determine what the distance from here to here is? So this is 1, x is 1, y is 1. (45, 45, 90 right triangle? So this r should be square root of 2. So even before we do the math, r should be square root of 2, and theta should be 3 pi over 4. Now let's go through the process and see if in fact that's true. Okay, so first off, we know that r squared is equal to x squared plus y squared. So out of your 4, anything that you do with these polars, with any conversion, you're going to use one or more of the 4 properties that we went over earlier. So here's one here. R squared is equal to x squared plus y squared. R squared is equal to negative 1 squared plus 1 squared. So r is the square root. Negative 1 squared is 1. 1 squared is 1. So r is the square root of 2. Okay. Now, in order to find the angle measure, we know that tangent of theta is equal to y over x. So tangent of theta is equal to y is 1, x is negative 1. So it's negative 1. Theta is equal to the inverse tangent of negative 1. So here you have to be a little careful because your angle is in the second quadrant. It's in the second quadrant. If you're using it, first off, we should know when tangent is equal to 1. 1 or negative 1. It's at what angle measures? It's at the 45s, right? So this angle, so our reference angle is 45 degrees, or pi over 4, but we know that this angle is in the second quadrant because x is negative and y is positive. So what's our relative angle in the second quadrant? That makes a 45 degree rotation with the x-axis. It's 3 pi over 4. Now, these are angles from the unit circle. So in these problems, you're going to have angles that are not necessarily from the unit circle. You use a calculator. Just keep in mind that the domain for inverse tangent goes from negative pi over 2 to pi over 2. So any positive angles with inverse tangent, it will give you an angle measure in the first quadrant. Any negative measure angles, it's going to give it to you in the fourth quadrant if you plug it into your calculator, but it will give it to you in the form of negative. So like negative 30 degrees. So it won't give you 330 degrees, it'll give you negative 30 degrees. So your negative angle measures, because the domain for tangent, in order to make it a function, goes from negative pi over 2 to pi over 2, keep that in mind. So it's always important to understand what quadrant your angle is in so you can make the correct choice. Okay. All right, so the conversions, those are going to be important because pretty soon we're going to start taking slopes of polar equations, etc. All right, ladies and gentlemen, please graph the following. Okay, please graph r is equal to. R equals 2. What does the graph look like? What is this the graph of? R equals 2. What is your graph? R equals 2. So what's the distance from the pole? 2. At what angle? Is it 2 units from the pole? Is it 2 units from the pole at 0 degrees? Is it 2 units from the pole at pi over 6? Pi over 4? Pi over 3? Pi over 2? 2 pi over 3? 3 pi over 4? 5 pi over 6? It's 2 units from the pole everywhere. So what is that the graph of? Oh, that's an awful circle. Okay, so you have a distance of 2 units from the pole regardless of the angle measure. It doesn't matter. The infinite number of angle measures between 0 and 2 pi, this graph represents all of those. Now, let's take a look here. Here you have r is equal to 2. If we wanted to find an equivalent rectangular equation for this, we're going to need to use one of these 4. Now, we have r equals 2. What we can do here is, why don't we multiply, or why don't we square both sides? If we square both sides, then we're going to get r squared is equal to 4. But we know that r squared is the same thing as x squared plus y squared is equal to 4. What's the equation? X squared plus y squared is equal to 4. This equation of a circle centered at 0, 0 with a radius of 2, which is exactly what you have here. You tell me. What is this? But what does it represent? That's the equation of a circle. Its center is 0, 0. So the equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where h and k are the center. So because your center is 0, 0, and your radius is 2, this is the same as r equals 2. Now, ladies and gentlemen, when you have r for a polar equation, r equals a constant, that is going to be a circle centered at the pole with your distance or your radius being that constant. All right, let's try another one. So this is the graph of r equals 2. Okay. Let's try this graph here. All right, how about theta equals pi over 3? Theta equals pi over 3. In your polar plane, what does this graph look like? So theta equals pi over 3. So at pi over 3, that's your graph. Now, all of these polar equations, we can also write them as rectangular. So this is a linear equation. You have a line. You have a y-intercept at 0, 0, at 0. You have some slope. So take a look here what we're going to do. If we take the tangent of both sides, then we get tangent of theta equals tangent of pi over 3. What's the tangent of pi over 3? I'm sorry, that took just a little longer than I thought. I'll ask the question again. What's the tangent of pi over 3? Square root of 3. Okay, so now you're going to get tangent of theta equals pi over 3. Just remember, at the 60 or pi over 3, at the 60 degrees, or the pi over 3, tangent is the square root of 3. At the 30 degree or pi over 6, tangent is 1 over square root of 3. Sine over cosine when you do the ratio. Sorry? I'm sorry, square root of 3. Thank you. Now, what's tangent in terms of y and x? Tangent of theta is equal what? Y over x. So you have tangent of theta equals tangent of pi over 3. Tangent of pi over 3 is the square root of 3. But now we can change tangent of theta into y over x. So y over x is equal to square root of 3. Here, if we multiply both sides times x, now you have y is equal to the square root of 3 times x. You have a linear equation. Your y-intercept is 0. Your slope is square root of 3. We go up square root of 3 over 1. Up square root of 3 over 1. So that's your graph there. Theta is equal to pi over 3. It's the exact same graph in the rectangular field, as y is equal to the square root of 3 times x. Okay, let's try another one. Okay, r is equal to secant of theta. What does this graph look like? R is equal to secant of theta. So the secant of theta we can change to 1 over cosine, right? So this becomes r is equal 1 over cosine of theta. Now if you think back to the 4 very important properties, if we multiply both sides times cosine of theta, you're going to end up with r cosine theta is equal to 1. But what is r cosine theta? X. X is equal 1. So that's the graph. So r equals secant theta is the exact same graph as x equals 1. And for x equal 1, that is just a vertical line at 1. So r equals secant of theta, there's your graph there. So that's just some of the things, some of the properties you're going to have with polar equations, going from polar to rectangular and rectangular to polar. Okay, what do you need to write the equation of a tangent line? You need a point and you need a slope. In parametric, we had parametric equations in the form of x of t and y of t. We had to find dy dx in order to find those slopes and relate it to a point. No different here. So here is the slope in polar form. So our slope in polar form is as follows. Dy dx is equal to dy d theta divided by dx d theta. So very similar to what we did with parametric, where dy dx was dy dt divided by dx dt. In polar, dy dx is dy d theta divided by dx d theta. Okay. Now, if dy d theta equals 0 and dx d theta not equal to 0, what type of slope are you going to get? So dy d theta is 0, dx d theta is not 0. What type of tangents? Horizontal. So that will yield a horizontal tangent. If, on the other hand, dx d theta is equal to 0, and dy d theta not equal to 0, that's going to yield a vertical tangent. Okay, so that's what we did too with parametric. You guys had a couple of problems on your exam that dealt with, well, when will we have a vertical tangent or when will we have a horizontal tangent? If dy d theta and dx d theta are both equal to 0 simultaneously, or why don't I just say at the same time, then no conclusion can be drawn. So that's kind of the same concept of the indeterminate. All right. Now there is a long drawn out formula in your book. So if you go back and you read your book, you're going to see a formula for dy d theta. Matter of fact, let me just show you. So here's that formula there. All right, you are 100% not going to learn how to take the slope using this formula. You will not. And this is for the couple of you who don't pay attention in class and you go back and read. Guarantee you're going to make mistakes with this. So, we will not use this. Okay? Huh? Because it works, but we're not going to learn it that way because there's an easier way to work with this. All right, so again, it's here, slope in polar form, but we're not going through this process. This is how we're going to do this. All right. Our best friend is x is equal r cosine theta and y is equal r sine theta. X is equal r cosine theta, y is equal to r sine of theta. Yeah. So let's say that we want to find the slope of let's see where slope. All right, so let's say we want to find the slope of r is equal to 2 cosine of 3 theta, and we want to find the slope dy dx at theta equals pi over 6. So here's what we know. We know that dy dx is equal to dy d theta divided by dx d theta. So what we're going to do is first we need to find a function or an equation for y in terms of theta and a function for x in terms of theta. Well, x equals r cosine of theta. Your r is equal to 2 cosine 3 theta. So x equals 2 cosine of 3 theta, because that's your r, times cosine of theta. X equals r cosine of theta. That's your r. Okay. So here, dx d theta is going to be first 2 cosine of 3 theta times the derivative of the second, negative sine theta, plus the second cosine of theta times the derivative of the first. So the derivative of the first would be 2. The derivative of cosine of u would be negative sine of u. So negative sine of 3 theta times the derivative of 3 theta, which is just 3. So dx d theta, this is going to be negative 2 sine theta cosine 3 theta minus 6 sine 3 theta cosine theta. Okay, so that is dx d theta. Now, we need to evaluate dx d theta when theta is equal to pi over 6. So this becomes negative 2 times sine of pi over 6 cosine of 3 pi over 6, 3 times pi over 6, 3 pi over 6, and 3 pi over 6 is pi over 2, right? So this first term here, that's going to be 0. So sine of pi over 6 is 1/2, sine of 3 pi over 6, or pi over 2, is 0, minus 6 times sine of 3 pi over 6 times cosine of pi over 6. All right, so you're going to get 0 minus sine of pi over 2 is 1, and cosine of pi over 6 is square root of 3 over 2. So that'll be minus 6 times 1 times square root of 3 over 2. So our final answer would be negative 3 square root of 3. So that's only for dx d theta. We haven't even done dy d theta yet. But dx d theta is negative 3 square root of 3. Any questions so far? All right, let's take a look at dy d theta. Okay, so as we go through the math there, so now for dy d theta, we need to have a function or an equation y in terms of theta. So we know that y is equal to r sine theta. And again, our r is 2 cosine of 3 theta. So y is equal 2 cosine 3 theta times sine theta. So y is equal to r times sine of theta. Dy d theta is equal to first 2 cosine of 3 theta times the derivative of the second, which is cosine of theta, plus the second, which is sine of theta, times the derivative of the first, and I think this one ended up being negative 6 cosine sine of 3 theta, right? So we just remembered that from before. Okay. Now, if we evaluate this at theta equals pi over 6, then you're going to get 2 cosine of 3 pi over 6 times cosine of pi over 6 plus sine of pi over 6 times negative 6 sine of 3 pi over 6. Well, the first part of our term here will be 0, right? Because cosine of 3 pi over 6, that's 0. So you're going to get 0 plus sine of pi over 6 is 1/2 times sine of 3 pi over 6, or pi over 2, is 1, so times negative 6. So our answer here would be negative 3. Now, oftentimes on the FRQs, you'll have a calculator to evaluate these, because these, you see, can be time consuming. dy dx is equal dy d theta divided by dx d theta. So from the two solutions we have dy d theta is negative 3, and dx d theta was negative 3 over square root of 3. So our final answer would be 1 over the square root of 3, or square root of 3 over 3. So for the polar graph of 2 cosine of 3 theta, at pi over 6, the line tangent to this graph, the derivative, the slope, would be 1 divided by square root of 3, or negative square root of 3 over 3. Okay. All right, so the last thing we'll talk about today is tangent lines at the pole. So tangent lines at the pole. If f of alpha is equal to 0 and f prime of alpha is not equal to 0, then the line theta equals alpha is tangent at the pole of r is equal to f of theta. Now this is important when you're graphing. You guys, we're going to take a look at some of the rose curves that we've done, and then we're going to take a look at the tangent at the pole, and you're going to notice something with those rose curves and kind of how they're, with the petals, and kind of how they're confined between those tangents at the pole. Okay, so let's take a look at an example of this. Okay, so let's say we have r is equal to, yeah. R equals f of theta. So in this case, r is a function of theta. So in this case, the example that we're going to do is r is equal to 4 cosine of 3 theta. So our f of theta would be 4 cosine of 3 theta, because that's our function of theta. So here, we're going to take a look. Well, actually, I don't want to do that one. Oh, no, we can do it. All right, so first thing I need to know is, where is this function equal to 0? So r is equal, so r is equal 4 cosine of 3 theta. So where is 4 cosine of 3 theta equal to 0? Is that the only place? Okay, so the first thing we're going to do, we're going to divide by 4. Then we're going to get cosine of 3 theta is equal to 0. Then we're going to take the inverse cosine of both sides. And we know that the inverse cosine and cosine they undo each other. They're inverses. So you're going to get 3 theta is equal to the inverse cosine of 0. Then you're going to ask yourself, well, where is the cosine equal to 0? At pi over 2? plus 2n pi, and 3 theta is equal to 3 pi over 2 plus 2n pi. So now, but we're solving for theta, not 3 theta. So we're going to divide by 3, and by 3. Divide by 3, 3, and 3. So for the first one, you're going to get theta is equal to pi over 6 plus 2n pi over 3. For the second one, you're going to get theta is equal to 3 pi over 6, which is pi over 2, plus 2n pi over 3. Now, we're looking for angle measures between 0 and 2 pi. So right away, we know that pi over 6, when n is equal to 0, okay, so at n equals 0, this part right here is 0, so you're going to get theta is equal pi over 6. When n is equal to 1, you're going to get theta is equal to pi over 6 plus 2 times 1 times pi, or 2 pi over 3. So 2 pi over 3 is the same thing as 4 pi over 6. 4 pi over 6 plus 5 plus pi over 6 is 5 pi over 6. Right? All right. So we know that we have pi over 6, we have 5 pi over 6. At theta equals pi over 2 plus 2n pi over 3. For n equals 0, you're going to get theta is equal pi over 2. Are there any more? From 0 to 2 pi. Now, this is true when n equals 1 for this one. We can. So for n equals 1, you're going to get theta is equal pi over 2 plus 2 pi over 3. Common denominator is 6, right? So that would be 2 over 2, 3 over 3. So you'd get 3 pi plus 4 pi over 6. So that's 7 pi over 6. Through with the rest of this, because so here at theta equals pi over 6, 5 pi over 6, and pi over 2. So what you end up with is that pi over 6, here's the graph of theta equals pi over 6. Notice that this also encompasses 7 pi over 6, which is what we got here. At pi over 2, which is another tangent, you're also going to get 3 pi over 2. And if you were to keep going, you would get 3 pi over 2. At 5 pi over 6, you're here. Well, when you draw the graph of theta equals 5 pi over 6, you're also going to get 11 pi over 6 as well. So this particular graph of 4 cosine of 3 theta is going to do this. It's going to go here. It's tangent here. It's tangent there. Back around here. And then finally, here. That's your graph there.